So the only difference between these two is that you have a 9x here and an x there. So if x is between negative 5 and 5, this will converge if 9x is an element of negative 5 and 5. Okay. So remember, they have to have a common interval. So if this one converges from negative 5 to 5, then this one would have to converge from negative 5 to 5. So to find that common interval, that means negative 5 is less than 9x, which is less than 5. Divide each term by 9. You have negative 5 over 9 is less than x, which is less than 5 over 9. Okay. So your interval of convergence is negative 5 over 9, 5 over 9. So it's a little more work than the other one. All right. So any questions on that one? All right.
Would it be appropriate, whatever is being done to the x, to do the opposite operation? Like for this one, you're multiplying by 9, so for each end of the inequality, you divide by 9. Is that always true, or is that just
Which part were you talking about? You said
for the second sum, we've got 9x over 5.
Yeah. Oh,
and
that should be
that's
to the.
only change. That's
Yeah, that's it.
X, right?
Yeah.
Okay. So we just do the opposite.
Yep, exactly. Once you set it up to where we have our known series with our known interval of convergence, then once you kind of match it up, then you just get that very same difference.
Take the original interval of convergence
Yeah.
and just kind of do to it whatever is being done to x in the second
Exactly.
sum. Okay.
Yeah, exactly.
So we're pretty much just looking at the bounds of it?
Yep, the interval fall. These are all the values in between negative 5 and 5 that series will converge.
So you're pretty much just look for whatever makes it 0. Or is it not? I mean, 'cause-
Not 0.
Well, because if you look at the interval, if you plug in 5 over 9, that's, well, I guess 1.
And it's whatever the smaller interval would be if it's encapsulated, right? So like, let's
Yeah.
say the original had x to the n, and the new one has x over 5 to the n, right? So you would multiply both ends of the interval by 5, right?
Yep, so if x to the n was between negative 5 and 5, then that means that x to the 5 to the power of n would be between negative 5 and 5.
Right.
Because that would be the only difference is the fact that you have an x to the n and x over 5 to the n.
Right.
Okay? But they would converge in that same area.
Right. Just depending on which one's like inside the other.
Exactly.
Right.
Yeah.
Okay. Cool.
Yep. So right back to that common interval. All right. Okay. So let's say, for example, let negative from n equals 1 to infinity of 3x to the nth power over n have an interval of convergence of, you have a bracket on the left, so negative 1/3 to 1/3. Nope, not really and. I'm thinking of the other problems. Okay, so we're going to find the interval of convergence of the negative sum from n equals 1 to infinity of 6x to the third to the nth power divided by n. So with this one again, you just want to kind of match it up. Okay. So we already know that the negative sum from n equals 1 to infinity of 3x to the nth power over n converges when x is an element of negative 1/3 to 1/3. Okay. So if we get our new series, I guess you can call it the new series. So the negative sum from n equals 1 to infinity of 6x to the third to the nth power divided by n, you can actually rewrite that. Negative sum from n equals 1 to infinity, we can make that 3 times 2x to the third to the nth power over n. Okay. So really the only difference here is you have 3 times 2x to the third and 3 times x there. So that means in this case, 2x to the third would have to be an element of negative 1/3 to 1/3. Okay. Now since it's not an absolute value, from here, you just have to find your new endpoints. So 2x to the third equals negative 1/3. Divide both sides by 6. Cube root. That means that x would have to equal negative cube root of 1 over 6. And 2x to the third equaling 1/3 is just x is equal to positive cube root of 1 over 6. Okay. So just knowing... Oh, sure. Yes.
Why is it 2x cubed and not 2x squared?
Oh, because what we did here is we have our 6x cubed, and all we did was factor out the 3. So in our original series, it was just 3x to the nth
So
power.
it doesn't matter that there's an x in the first one? Because the difference really between the two is 2x squared, because there's an x in the top one, but that doesn't matter.
Oh, no, not at all. The only thing is when we find our interval of convergence, these are just all the possible converging x values.
So it's just dealing with the coefficient that's different?
Yep. So as long as you match up the coefficient, whatever's next to that coefficient is now what you have to have in that
So
interval.
it's x compared to 2x?
Yep, 2x cubed. Exactly. Okay. So now, since we know the endpoints of our interval of convergence, pretty much know that everything in between would match up. Okay, so we know that the negative sum from n equals 1 to infinity of, where's I? Of 6x to the third to the nth power over n converges when x is an element of the negative cube root of 1/6 and the cube root of 1/6.
Shouldn't be negative cube root. Shouldn't it be a bracket the first?
Oh, yep, thank you. Slide that up a little bit. All right, so any questions on that one? Yes.
When do we know when the interval of convergence has a bracket?
Oh, it all depends on your, oh, yep, on your, what is that called? Not the interval of convergence, whether or not your given interval of convergences have brackets or parentheses. And actually there was one that had the bracket and parentheses, and I was going to do an example of that one, but I'll leave that to y'all. Try to make you think a little bit. Can't give you a roadmap to every question.
Well, yeah, is there a way, like, if it's not given, to lead you to having a bracket? Or is that just something you base on whether or not it has a bracket to begin with?
with the one, at least the ones that I saw, they pretty much gave you whether or not it had a bracket or parentheses. So
Okay.
I think in order to, you'd have to go through an entirely different process to figure that part out. It's just, you'd have to use the ratio test. Then once you use the ratio test, then test your endpoints and see if they're less than 0 and see if they're divergent or convergent. If you test your endpoints and you find out that the endpoint is convergent also, then you use the bracket. Then the endpoint is not convergent, then you use the parentheses. So they kind of cut out that entire middleman for you.
You said, what test would that be using?
The ratio test. So you do the ratio test to find your interval, and then once you find your interval,
Yeah.
you plug in your, you can use any test for the endpoints.
Okay.
Then once you find out the interval for the endpoints, you say, okay, for this endpoint, it diverges. But for this
Then
one,
just
it converges.
taking the limit as it approaches that?
Depends on which test you use. So if you use let's say if you use it for 1/3, and if you use the test for divergence or the integral test or the p-series, whichever test you use,
Okay.
then that's how you can decide whether or not
Just to converge.
1/3. Yeah, so you just want to find out. Because at first, you'll find the interval of convergence just with parentheses on both sides.
Right.
Then once you check this endpoint, you say, okay, I checked this one. It converges for -1/3 also, so that changes to a bracket. Then once you check at 1/3, you say, nope, it diverges for 1/3, then that's why it's parentheses. So like I said, they kind of did all that work for you. Doesn't seem fair, but they did it. All right. And, okay. And I actually have one more to go, which should take probably about 5 minutes. And that's the Cauchy product of a series. Okay. So again, we let the sum from n equals 0 to infinity of c sub n times x to the nth power converge to f of x. And the sum from n equals 0 to infinity of d sub n times x of n converge to g of x on a common interval. Okay. So let's say for 1, we have the sum from n equals 0 to infinity, c sub n times x to the nth power, times the sum from n equals 0 to infinity of d sub n times x to the nth power. Okay. That's going to equal, and we'll actually get to the example and show you how we end up with this one, c sub 0 d sub n plus c sub 1 times d sub n minus 1 plus c sub 2 times d sub n minus 2, and it keeps on going till you get to c sub n minus 1 times d sub 1 plus c sub n times d sub 0, which is equal to the sum from n equals 0 to infinity of c sub k times d sub n minus k. Okay, and let's say if we let this entire sum equals e sub n, not the 2.7189 blah 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 e, but that's just a variable e. Okay, so c sub 0 d sub n plus c sub 1 d sub n minus 1 all the way to c sub n times d sub 0. Then the sum from n equals 0 to infinity of that e sub n times x to the n converges on the common interval. Oh, the common interval I. Yes.
What does it say it equals for the first part?
1 or 2, or this one. Oh, C sub k, D sub n minus k.
What does K represent?
Oh, k is just some, but when you have the, was it, as n grow, or k grow, oh, that should be k minus 0. Nope, that's it. Oh, let me see. Actually, k is equal to n, but n is just going in reverse, so. Let me see if I can get a. Let's see. So k is really just your values here that match up. So if you have c sub 1, n minus 1, c sub 2, n minus 2. So that's your k value. Just kind of give it a general definition. I'm still writing. All right, so let me do a quick example. Oh, anyway, I'll leave that up for a second. All right. So this one is actually close to the definition given. Okay, so we're going to find the first 4 non-zero terms of the Cauchy product for the sum n equals 0 to infinity of x to the nth power for absolute value of x is less than 1 when it's multiplied by itself. Okay, so the first thing we're going to notice that the sum from n equals 0 to infinity of x to the nth power, x to the 0 is 1 plus x squared plus x cubed plus x to the 4th, etc., and so on. Now, if you multiply it to itself, that's going to give you 1 plus x squared plus x cubed plus x to the 4th, and it keeps on going, times 1 plus x squared plus x cubed plus x to the 4th, and it keeps on going. Okay. So if we get our 1 and we distribute our 1 to each of those terms, 1 times 1 is 1 plus x squared plus x to the 3rd plus x to the 4th, and I'll go down plus x to the 5th, and it keeps on going. Okay. Now if we distribute our x times 1 is x, x times x is x squared. X times x squared is x to the third. And you get x to the fourth, x to the fifth, and it keeps on going. Clean that up a little bit. Now if you get your x squared, multiply that by 1, you get x squared plus x to the third plus x to the fourth plus x to the fifth plus x to the sixth, and it keeps on going. Okay. Now if we do our x to the third, same thing. You multiply that by 1, you get x to the third plus x to the fourth plus x to the fifth plus x to the sixth, and it keeps on going. Okay. So really all we want are the first 4 terms. Okay. So here you have 1 plus x is 2x plus x squared plus x squared plus x squared is 3x squared plus x to the third times x to the third times x to the third times x to the third is 4x to the third. And it keeps on going and like that. Okay. So really, if you look at this, you have n plus 1 times x to the n. Okay, the sum from n equals 0 to infinity of n plus 1 times x to the nth power is equal to 1 plus 2x plus 3x squared plus 4x to the third, and it keeps on going. And this is your Cauchy product. All right, so any questions on that one? All right, so a couple other examples, I'll just add those to the scan notes. Okay, are there any questions? Okay, if there are no questions, I'll see you on Monday. Yes,
When will we get to see our exhibits?
I'm going to try and have them done by this weekend, hopefully by this weekend. At least that's the plan.
Your recording is still going.
Oh, thank you.